Does the universe have an end? This question is one of humanity's oldest curiosities. Anyone who has ever looked up at the night sky has wondered about it. If all the stars, galaxies, and cosmic structures we see have a boundary, what could exist beyond that boundary? Is it emptiness, a new kind of energy, or are we just a tiny part of something far larger than we can imagine? Let's break this down together. Today, we'll explore how the universe began, how it expands, the scientific theories trying to explain its possible end, and what these theories really tell us. Because understanding the end of the universe is actually an important step toward understanding ourselves. First, let's start with the foundation. The universe is expanding. When Edwin Hubble measured this in the 1920s, everything changed. Galaxies are moving away from us and the space between them is stretching. The universe is not a static structure. It's like a giant fabric constantly being pulled apart. And this expansion isn't just continuing, it's speeding up. The force behind this acceleration is something scientists call dark energy. Dark energy makes up roughly 68% of the universe, yet we don't know what it actually is. All we know is that it pushes galaxies apart, and this acceleration shapes almost every theory about how the universe might end. Now let's look at the three major scenarios scientists discuss. The first is the Big Freeze. In this scenario, the expansion continues to speed up. Galaxies drift so far apart that the night sky grows darker and emptier. Stars slowly burn out. New stars stop forming, and the universe becomes a cold cosmic desert. Energy spreads so thin that even matter becomes useless. It's a slow, quiet fading, a kind of cosmic death. The second scenario is the Big Crunch. If the universe had enough matter and energy to slow its expansion, the stretching of space could eventually stop and reverse. The universe would collapse inward, just like letting the air out of a balloon. All matter would compress into a single point, and this collapse might lead to another Big Bang. It's a beautiful idea, a cyclical universe. But today's data shows expansion is speeding up, not slowing down, so this scenario seems less likely, though not impossible. The third scenario is the most dramatic, the Big Rip. If dark energy grows stronger over time, it could eventually overpower everything. Galaxies, stars, planets, and eventually even atoms would be torn apart. The universe would literally rip itself to pieces. It sounds like science fiction, but mathematically it's not off the table. But is there a physical end to the universe? A wall, a boundary, an edge? Here's the interesting part. The universe has no edge. It isn't like a box with walls. Instead, think of it like the surface of a balloon. If an ant walks along the surface, it never reaches an edge because the surface curves in all directions. We're living on the three-dimensional surface of this four-dimensional structure. No matter where you go, there is no wall to hit. What we call the edge of the universe is really just the edge of what we can see. Because light has a speed limit, we can only observe 13.8 billion years worth of light reaching us. That's why the observable universe looks like it has a boundary. Beyond that boundary, we simply don't know. There could be galaxies similar to ours, completely different physics, or even regions where time behaves differently. Another theory suggests that the universe may be infinite. If it's infinite, then somewhere out there might be galaxies just like ours or even versions of us. Quantum probability doesn't rule that out, although it remains theoretical. All these ideas show us one thing clearly. We don't know the universe's fate with certainty. But our observations and mathematical models give us powerful clues. To truly understand the future of the universe, we need to solve the mystery of dark energy. Maybe one day we'll know for sure how the universe will end. But for now, thinking about the end of the universe helps us understand how special our existence is. In this enormous cosmic landscape, we are just a tiny point, yet the fact that we're here, wondering about it, is extraordinary in itself. No matter how the universe ends, we remain its most curious observers.